Hey guys, I'm here at home. I miss you all. I hope you had a good break. If you forgot what I looked like without my mask on, this is it. I am not at school, obviously. Our family got COVID over Christmas break, but I'll be back on Monday. But I wanted to say if I'm a little stuffy or anything, that is why. But we're going to do our notes videos like this. Hopefully you can access them. Obviously you can't talk to me, even though I like to ask questions and stuff. So if I ask a question, sometimes I might say, talk to a partner about it, or answer it in your head, or something like that. And also, if at any time I go too fast and you need to pause the video, just pause it and catch up, and then you can continue it. These are kind of long notes today. We always have long notes, but these are kind of long, so concentrate, be serious, and let's see if we can get through these. Alright, today we're continuing with chapter 4, but I'm kind of mushing two sections together. So this is technically 4.4 and 4.5, if you really care about that sort of thing. I'll write it over here. I just kind of took the highlights from each section and mushed them together, and I'm renaming it Examining Graphs of Polynomials. So that's what we're talking about today. These are long, so I'm going to jump right into them. Some of the stuff is a review, and we've looked at it with quadratics especially, but not with all kinds of different polynomials. So first word is the word degree. We're going to define that. And it is the highest exponent. The highest exponent is the degree. So if you have something like x to the fourth minus 5x to the third minus 3x squared plus x minus 4, I don't know, something like that. The highest exponent is the 4, so the degree here is 4. The degree is just 4, not the fourth power, anything like that, just 4. So we're going to link that to end behavior, which we already know what that is. It's kind of like where the arrows are going. So this is a little rule. We're going to skip a line, and I'm going to show you the rule. If end behavior is the same, like they're going in the same direction, both up or both down, the degree is even. Okay, so that makes sense. X squared is a parabola, is a quadratic, and they're both going up, usually. So that makes sense. So if we can make the connection, if end behavior is different, for example, one goes up and one goes down, the degree is odd. And we're going to look at some of these. I'm also going to underline and highlight those two things. The same, it's even. Different, it's odd. And I'm going to put a little box around it, because who doesn't like a nice box around their rules? Okay, so let me show you what I mean in this example 1. We're going to draw 3 little mini graphs, very small. The first one is a lovely parabola, the parent function. Next one is a little squiggly guy, and this one's really squiggly. They don't have to be perfect, just kind of rough like that. So, the first one, is the end behavior going in the same direction, both up, both down, or is it going 2 different directions? Tell your partner, tell a friend. Same direction or opposite directions? It's going in the same direction. Okay, so these are going in the same direction. So the degree, the highest exponent of this, is going to be an even number. It's x squared. We know that because this is a parabola. How about the second one? Is it going in the same direction or different directions? It's going in different directions. So this one is odd, and it's actually, you don't have to know this, but it's x cubed is the first term there. And the last one same direction or different directions. It is going in the same direction, so it's another even number. And this is actually x to the fourth. Those are the parent functions of those graphs. So just the original functions without them moving around or anything. All right, so that's in behavior. We're going to be looking at 4 different rules, sets of rules. So that's the first rule for in behavior. Same direction even, opposite direction is odd. Next thing we're going to be looking at, we're going to define the word leading coefficient. Leading coefficient. You could probably guess what this means. It means the first coefficient. So if we have negative 3x squared plus x minus 2, something like that, then the leading coefficient is that negative 3 right there. Okay, and basically we already know this. If that A is what we call it, A, B, and C, remember, if the A is negative, we know it's going to be flipped upside down, remember? And if the A is positive, it's going to be right side up. This is just an extension on that, basically. So here we're looking at the direction that the function goes. So basically, if the function is pointing down, upside down, or it's going downhill, like for example, a line, if the line is going downhill, then the leading coefficient, that A, is negative. If the function is pointing down or going downhill, then that leading coefficient is negative. We already know this because we looked at that with the A in front of a quadratic function, whether it's smiley face or frowny face, remember? So if it's negative in front, it's going to be a frowny face. But this applies to all functions, not just parabolas. So if the function is pointing up or uphill, then the leading coefficient is positive. Smiley face. Okay, so I underlined and highlighted, and I'm going to box this in as well, and then we'll do some examples of that. Oh my gosh. Got to change it over. Okay. All right, so we'll do some examples of that as well. Just going to wait for everybody to catch up because I went pretty fast on that one. So we're going to do example 2, and we'll do some examples of this. This time we're going to have 4 little graphs instead of 3. The first one is a parabola that's going to be frowning. The next one is that same squiggly line. And the same squiggly line from before. And then a line like this. Alrighty. So first one's easy. Is that pointing down, going downhill, going up, going uphill? It is pointing down. So that means the leading coefficient is negative. And you can also do this the other way too. If the leading coefficient is negative, then that means it's going to be pointing downhill. Okay, this is what I mean by uphill and downhill. If a little guy was walking on this, going from left to right, this way, would he be walking up or down? He would be walking up. Okay, so that's what I mean by uphill or downhill. So this guy is going uphill, which means that the leading coefficient is positive. Okay, these two arrows are pointing up, so that means this is also positive. And now a little guy walking on here. If he was walking from left to right, he would be walking downhill. So that one is negative. I hope that makes sense about the uphill and downhill. If it helps you to draw a little guy on them, draw a little guy on them. See how they walk. All right, so 2 out of the way. We're halfway there. We talked about uphill, downhill. We talked about in behavior. Now we're going to talk about zeros. Please lean to your neighbor and tell them what a zero is. What is a zero? A zero is where the function crosses the x-axis. It is an x-intercept, also known as solution or root. So for this, we have the rule that says if the y values, of a function change signs, if the y values of a function change signs, then there is a zero between those values. Okay, so I'll show you what that means. Let me box this one in. It's really easy to tell on a graph where the zeros are. So, for example, if you just have something random like that, you can tell that there are 3 zeros. 1 here, 1 here, 1 here. But what if they don't give you a graph? What if they give you a chart? And that's what we're going to be doing. I'm going to give you a chart. So this is example 3. The directions are find the zeros. Whoops. And I'm going to be giving you a chart. So X and Y. And 1, 2, 3, 4, 5, 6, 7. You need 7 lines underneath that. A little T-chart, X and Y. The X's are going to go from -2 to 4. So fill it in, -1, 0, 1, 2, 3, 4. And the Y values, whenever you're ready, are -29, -7, 1, 1, -1, 1, and 13. So let's look at our rule again. When the y values of a function change signs, then there is a 0 between those values. Okay, so -29, we start negative. So whenever we change positive, there's a 0 there. So -29, -7, +1, okay, right here. We changed negative to positive. So there's a 0 in between -1 and 0 somewhere. We can't be sure because from where we're just given a chart, we can't really see what the function looks like. So we don't know where exactly it crosses, but it's between -1 and 0 on the x. Okay, keep going. So we had +1, now another +1, now a -1. Oh, right here, we changed from +1 to -1. So there's another 0. Keep going. -1, +1. Oh my, another one. We went positive, negative, positive. This time we switched from the -1 to +1 again. Okay, and then +1, +13. So that's it. So how many zeros are there? Tell a buddy. How many zeros? 3. 3 zeros. So over here, I'm going to write, there are 3 zeros. And let's tell them where. And we're going to use the x's. Okay? So I'll write over here. Use the x's. So we're going to say between, what was the first one? Between -1 and 0 on the x's, right? It changed -7 to +1, but in between on the x's, it's between -1 and 0. The second one was between 1 and 2. And the third one was between 2 and 3, right? Alrighty, so that's done for that one. When it changes signs, then that's a 0. Like I said, it's very easy to tell on a graph, but we don't always have a graph. There's one more thing we want to talk about. We've talked about in behavior and leading coefficients and zeros. Now the last thing we're going to talk about is extrema. Do you remember what extrema means? It means the minimum or maximum. The minimum or maximum, and we have some rules for this as well. All right, so two rules. If the y values of a function change from increasing, like the numbers are going up, to decreasing, all of a sudden the numbers go down. Okay, imagine in your head a roller coaster increasing and then decreasing. Would that be a minimum or a maximum? Up and then down. Tell your partner, would that be a minimum or maximum? It will be maximum, right? There will be a maximum. Okay, if the y values go from up, 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 and then all of a sudden they start going down, 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 that is a maximum. It's like the top of a roller coaster. So, on the other hand, if the y values of a function change from decreasing now, they're going down, to all of a sudden increasing, coming back up, there will be a minimum. Okay, and I'm going to underline increasing to decreasing max, D to N is min. And I'm going to box this one in just so that it's easier to find when you come back and look at your notes when you do the assignment. It'll be easier to find. All right, once again, we can locate mins and max very easy. Just real quick, if you had a lovely thing here, lovely chart, here is the max, here is the min, or a graph I mean, but we do not have a graph. We have a chart. I'm going to give you another T-chart. So let's see if we can figure it out. Example 4. Find the extrema. Find the extrema. Okay, this time, x and y graph again. This time you need 8 spaces. 1, 2, 3, 4, 5, 6, 7. I need one more. Okay, and this time we are going to go from -2 to 5 now. So -2, -1, 0, 1, 2, 3, 4, 5. And then our y values are -17, 0, 3, -2, -9, -12, -4, and 8. Okay, personally, I'm a visual person, so I can't just look and see like -7, 0, 3, -2. Like, I just see a bunch of numbers. So what I do is kind of imagine what the graph would look like. So -7 might be like way down here, or -17. Then 0 would be up a little higher. Then 3 would be up a little higher, and I just make dots for myself. It doesn't matter where they are. Obviously, from -17 to 0 and 0 to 3 on my graph, it looks like the same amount of space, but we know it's not really. I'm just trying to get the general shape of the graph. So here, let me label them. Negative 17, 0, 3. And then the next one goes to negative 2, so that's back down again. And then negative 9 is down. Negative 12, even further down. Negative 4 is up a little bit. And then 8 is way up. So here is the general shape of this graph. And now it's really easy to find the mins and the max. All of a sudden, we were decreasing. Well, I guess we were increasing, weren't we? We were increasing and then blah, blah, blah. Anyways, that's what I do. But you can see the general shape right here and right here are our max and our min. So right here, there is a, let's see, there is a max at 0, 3. And there is a min at 3, negative 2. And that is kind of what I do. If it makes sense to you, the actual rule is look and see where it's increasing, and then it starts to decrease. So here, obviously, it's increasing. And then from 3 to negative 2, it drops. And then from negative 12 to 4, it starts increasing again. So it just is up to you. I personally can't think that way. I have to draw it out for myself. But it's up to you. So those are all of the notes. I know it was a lot. We have 4 different kind of sets of rules that we looked at. You do not have an assignment today, you lucky dogs, but you will have one tomorrow. So just get ready for that and have a great day.